In this video we will look at performing sign analysis of rational functions. A rational function is a quotient or a division of a polynomial by another polynomial. Our strategy that we're going to be using, we start by factoring our polynomial as much as we can. So our example down here has already been factored to save a little time. We will then find the roots or the zeros of each factor and divisor. And so we need to look at both the top, the numerator, and the bottom, the denominator, and find out where each factor of the numerator and denominator go to 0. And so those will define some key points. Using those points, we'll create a number line called our sign analysis line, and we'll record the zeros which come from the roots of the numerator, and the breaks in the graph which come from the roots in the denominator. We need to mark both of those on our line. Well, this creates a series of intervals. We need to test a point in each interval to decide what sign our function has, and then when we're done, we'll use our sign analysis number line to interpret we'll interpret our sign analysis number line in the context of a specific question. Alright, let's give it a go. We start by looking at the top, or the numerator. We have two factors, and so we need to ask ourselves what will make x plus 4 equal 0, and what will make x squared minus 3 equal 0. These give us our roots, or our zeros of our rational function. We have 1 at x equals negative 4, and as we isolate x in the other example, we discover that x is two values, plus and minus the square root of 3. Because 3 is between the squares of 1 and 4, we know that this is somewhere between plus and minus 1, and plus and 1, well, between 1 and 2, and between minus 1 and minus 2. Alright, we're going to be putting these on a number line. Let's do that right now. Alright, so at negative 4, we have a 0. And we need to be sure that we mark why we're including a point. This is where the function equals 0. Let's put minus the square root of 3 and plus the square root of 3. And those are my other points where my function equals 0. Great. Now we'll look at our denominator, and we have 2 points where the function has a break, or where there's a discontinuity. We look at x plus 1 equals 0 and x minus 3 equals 0, and that gives us two discontinuities. One is at negative 1 and one is at 3. Alright, so let's see where those are placed. Negative 1 is between our roots, and so there's a break. Actually, let's write discontinuity with a DC, and at 3, which is way to the right, that's a second discontinuity, and this sets up my number line in order to be able to test what signs I have. Alright, so we now have our first 3 steps done. The way we test signs is in each interval we will choose an x value. Just to remind you, the value on the bottom is representing my x value, and we're recording the sign of my function above the number line. So I might, for example, pick a number of negative 5, and if I put negative 5 into the formula, negative 5 plus 4 is minus. If I square negative 5, I get 25. 25 minus 3 is positive. Negative 5 plus 1 is negative, and negative 5 minus 3 is negative. So we can see that we have 3 negatives and 1 positive, making my overall sign negative for that interval. We might now pick a point like negative 2, and again I think about each factor, and I'm going to plug or substitute negative 2 in. Negative 2 plus 4 is positive. Negative 2 when squared is 4. 4 minus 1 is positive. Negative 2 plus 1, that's negative. And negative 2 minus 3, that's negative. I've got 2 negative factors, and so overall that factor will be positive. If I were to take a number between -1 and -3, might be a pain to try to think of what that would be, but an example might be negative square root of 2. And so negative square root of 2 substituted in, I'll get positive -2 squared is 2. 2 minus 3 is -1. Negative square root of 2 is further left than -1, so that's negative and negative. I now have 3 negatives, so overall we're negative in that factor. And I would proceed to do this for each of the intervals. Between -1 and the negative square root of 3, I now positive. A number between square root of 3 and 3, like 2, I would get a negative. And a number bigger than 3, I again end up being positive. So this is my sign analysis summary. I'm going to use this to help answer questions related to inequalities. Different inequalities will give different answers, but we'll use the same sign analysis summary. For example, if I ask the question, where is my function greater than 0? I'm going to be looking on my sign analysis summary for where I have positive values coming out. And I might, for example, represent that with a number line. I'm just going to mark the intervals. And we should always pay special attention to the endpoints. So here we're looking for greater than 0. And so at -4, it's not greater than 0, it's equal 0. Negative root 3, 0. -1 is undefined. Square root of 3, 0. And 3, it's undefined. So I will not be including any of my any endpoints of the 3 intervals. My solution set will be the intervals -4 to negative square root of 3 as a union with -1 to the square root of 3 union 3 to infinity. If I were to ask instead a question, where is f of x greater than or equal to 0, I have the same basic intervals, but now I'm going to be filling in the endpoints where the function equals 0. So if I go back, -4 is coming from a factor in the numerator, so my function actually would equal 0 there. Negative square root of 3 and positive square root of 3 also come from the numerator, but -1 and 3 both come from my denominator. Those are points where it's undefined. My solution set will only include the endpoints of intervals where I'm equal 0, not undefined. So here is my solution set. Same intervals, just do something different with the endpoints. If I were to solve for the inequality less than 0 or less than or equal to 0, I would choose the intervals where it's negative. That's how we do sign analysis to solve inequalities related to rational functions.